Hi, today's lesson is going to be on, let me make sure we can all see. It's going to be on multiplying and dividing positive and negative numbers. And I want to make sure that we can see my screen. I'm afraid I just messed up. Okay, Tashana, can you still see me?
I can see you.
Okay. And my screen, I lost all my controls. That's not good. Okay. Okay. I'm going to stop the recording.
This conference will now be recorded.
Hi, today's lesson is going to be on multiplying and dividing positive and negative numbers. Tashana, can you see the PowerPoint that I've got set up, or can you not see it?
I can see it.
Okay, you can see it. Weirdly, I can't see it on my screen, but that's fine. Most of the problems that, or not most of, many of the problems that we'll be working through today came from the pre-algebra packet that comes from the Number Power book. So the packet looks something like this. This is going to be kind of part 2. Last week I did a lesson on adding and subtracting positive and negative integers, and I consider that a very, very challenging lesson. Actually, multiplying and dividing the positive and negative numbers is a little more simple. I want to review some vocabulary before we get started. The first one is positive numbers. Again, when I say a positive number, it means any number that's greater than a 0. It's a number on a number line that will always be to the right of 0. So all the numbers over here in blue are positive numbers. You're going to see those written in many different ways. This 18 is written the way that we typically would see the number 18 written. Sometimes when someone's making a point that it's a positive and not a negative, you'll see it written with the positive sign. Many times I will do that throughout this lesson. And very commonly, you will see positive and negative numbers written within parentheses. Now that we're typing on a keyboard and we don't have access to the raised positive or negative sign, you'll see parentheses used just to clarify that that would be a positive or a negative number. So negative numbers, numbers that are less than 0. On the number line, these numbers in red on the left side of 0. Again, negative 18 would typically be written like that, but you also will see it within parentheses. They mean the same thing. The next vocabulary term is algorithm. That's just a fancy word that means the rules for performing a math procedure. So I use the correct vocabulary because you might be asked a question in the future where they throw that term in, and I just want you to be familiar with hearing it. And within this lesson, we're going to learn the algorithm or the rules for multiplying and dividing when negative numbers are involved. Before we get started, I designed something that I call a pretest. This helps me kind of gauge the audience. Where are you at before this lesson began? So I don't really expect you to get all of these questions correct, but the more that you get correct, the more it helps me to know how to gear the lesson. So let's go ahead and get started. The first one we're going to answer is -5 times by a +5. So Tashana, do you want to try to answer that one? Or I could just do the thing where I say, freeze your screen, answer on your own. Do you want to try and answer?
It's -45.
-45 is correct. Excellent. The next one is 8 times by -2. What do you think that one's going to be?
Is it 16? No. Let me see.
Actually going to be
Oh, negative
negative
16.
16. My feeling is you probably know the rule of why it would be a negative 16, but we'll get to that. The next one is negative 10 times by a negative 7. What would that be?
Positive 70.
You're awesome. And 3 times 4.
12.
Okay. You, I can tell, Shauna, are a very strong student in the subject area. So we'll go through the lesson pretty quickly. If there's time at the end, I have a whiteboard set up. So we could maybe try some more advanced multiplication problems, but we'll see. We'll see how it goes.
Okay.
Okay, so in the packet that from the Number Power book, the algorithm is written like this, and it's very wordy and it looks very complicated, but bottom line, if you look at where it says positive times a positive equals a positive, negative times negative equals a positive, positive times negative equals a negative, negative times positive equals a negative. That's the most important part. I kind of rewrote that algorithm for myself to be more simple. When you're
Okay.
multiplying, if the signs are the same, it's going to be a positive answer. The signs are different, it's going to be a negative answer. On these, 5 times 7, those are both positives. So, Tashana, is our answer going to be, when we have a positive times a positive, will the answer, what kind of an answer will we get? What will the sign be?
A positive.
Good. And so, 5 times
35.
7 would be what?
A positive 35.
You're awesome. And you're also really good at your math. Oh, I'm sorry. If we had a negative times a negative, what would our answer be? A positive or a negative?
It's going to be a positive number.
Nice job. Excellent job. And that's the one that's the most confusing for most students. But you told me that 5 times 7 is going to be a positive 35, and you're correct. Negative 5 times by a negative 7 is going to be what, Tashana? Do you know?
A positive 35.
Nice job. How about 8 times 9? Those are both positive.
It's going to be positive 72.
You're awesome. And negative 8 times by negative 9, what will that be?
A positive 72.
Fantastic. There is a trick for multiplying by 9. I call it the finger trick, Tashana. Are you familiar with that trick at all?
No.
Okay, I'm going to show it to you. It sounds to me like you've got your math facts memorized. You're not really a student who needs this trick, but I've run into a lot of students at Seeds that I've gone over this with. So if we've got a problem like 8 times 9 or 9 times 8, they're the same answer. When we're multiplying, it doesn't matter which number comes first. It's going to have the same answer or the same product. So one way to find that answer when you're multiplying by 9, only works with 9s, is you put your fingers down in front of you like the picture shows. And because we're multiplying 9 by 8, you start counting from the left side and you count until you get to the 8th finger. Tashana, can you see the blue numbers up here and the red numbers? Okay, good. I wasn't sure you'd be able to. So you can see when they counted to the 8th finger and they folded that one down, now you can read the answer to the problem to 8 times 9. There are 7 numbers on the left side of the folded finger, 2 numbers on the right side. So our answer is 72.
Oh, that's awesome.
Yeah, it's really cool. I had a student teach that to me years ago. So let's try doing it again with 4 times 9. So go ahead and on your own fingers, build 4 times 9. Remember, you put your fingers out, start from the left side, count to the 4th finger, and fold that one down. See if you can make it work. And then my guess is you already have the math fact memorized. What was it?
36.
Nice job. And so the picture would look like that. And the answer is 36.
Oh, I gotta remember that. That's awesome.
It is a really cool trick, but it only works with nines. And so anytime you're multiplying a number by 9, a single digit, the numbers 1 through 10 multiplied by 9 all work.
Awesome.
So multiplication practice. I think you're going to do pretty well with these. I'm going to have you answer in 2 parts, even though I know that you don't need that level of help. But this is a positive times by a negative, and so we need to build that algorithm. So when we have a positive times a negative, what's it going to equal to, Shauna? What kind of a sign will it be?
A negative.
Nice. So negative times by a positive will be a negative, and a positive times a negative will be the same thing. So for 3 times negative 9, it is going to be a negative. Do you know the answer to that one, Tashana?
7.
Nice. Perfect. So now we have negative 3 times by 9. What's that going to equal?
A negative 27.
Perfect. How about 7 times by negative 5?
Negative 35.
Perfect. How about negative 7 times by 5?
A negative 35.
Perfect. Okay, so remember, when multiplying, if the signs are the same, it's going to be a positive answer. Different signs, it's going to be a negative answer. So I've got some more practice. Some students I know at Seeds can benefit by the use of a hundreds chart. That's not really necessary for you. So go ahead and just answer, Shauna. 8 times by negative 2, what's that going to equal?
A negative 16.
Perfect. 5 times negative 7?
Negative 35.
Nice. Negative 9 times by negative 2.
Positive 18.
Perfect. Negative 4 times positive 3?
Negative 12.
Yep. 11
That is negative 22.
Perfect. How about negative 5 times by negative 9?
Positive 45.
Yep. Negative 6 times by positive 6?
Negative 36.
Yep. 10 times by negative 15?
A negative 150.
You're awesome. So Tashana, I think you know, I just want to verify, anything multiplied by 10, you just add a 0 to the factor that you're multiplying by. Did you know that one?
Yeah.
Let's try negative 4 times by negative 4.
A positive 16.
Perfect. Negative 9 times negative 9.
Positive 81.
Yep. Okay, sometimes you're going to be multiplying by more than 2 numbers. And so there was an algorithm in the packet that looks something like this. Multiply all the numbers together. If there's an even number of negative signs, the product, which means the answer, is going to have a positive sign. If there's an odd number of negative signs, the product will have a negative sign. So in my brain, it's more simpler to think, count the negative signs. If it's an even number, it's positive. If it's an odd number, it's negative. So let's try some of these. We'll start with A. So first of all, there aren't any negative signs. So Tashana, will the answer be a positive or a negative?
Positive.
It will be a positive. And go and multiply those. And I was going to say, some people might have an easier time if you think about you're allowed to change the order of the factors. So you don't have to do 2 times 3, then multiply by 4, then by 5. You could regroup them. You could do something like 2 times by 5 equals 10, and then multiply the other numbers. But however you want to multiply it, Tashana, go ahead and come up with the answer for me.
It'll be a positive 120.
You are awesome. Brianna, I see that you joined the lesson. Hello.
Yes. Hey.
Would you like to answer along with us, or do you want to just listen and Tashana can answer? It's up to you. Either way is good.
Let me get my notebook and my pen.
You didn't know I was going to make you work.
Oh yeah.
So, Brianna, we were talking about multiplying and dividing when you've got negative numbers involved. And
Negative.
with negative and positive numbers. And so we had just talked about when we've got, let me go back a little bit. When we've got the signs are the same of the two numbers being multiplied, our answer is going to be a positive. And if the signs are different, the answer was going to be a negative. And so let's just look at a couple of these problems. Let's do these again. Brianna, I just want to kind of get an idea of where you're at with all of this. So we've got -9 times by a +5. Those signs are different. So the sign of our answer, will it be positive or a negative?
And wait, can you repeat that?
Yep. Okay, so I'm looking at this first problem, -9 times by a +5. The two signs of our factors are different. And so for our answer, will that be a positive or a negative answer?
I think it'll be a negative.
It will be a negative. Nice job. And then all you have to, oh, and I'm sorry, I already gave you the answer of 45. I hadn't meant to do that. The answer will be a negative 45. Now, how about 8 times by -2? Will our answer be positive or negative?
It'll be positive.
When the signs are different, anytime, like this is a +8 and this is a -2, so our signs are different. So our answer has to be a negative number.
Okay.
So do you know what would 8 times -2 be then? What would the answer to that be?
So positive 16.
Except for it would be a negative because our signs are different, but it would be a negative 16. Okay, let's try -10 times by -7. This time, the signs of both of our factors are the same. They're both negative signs. So when our signs are the same, what will our answer be, positive or negative?
Negative.
You would
or
think
positive
so.
Because they both the same.
People think that a negative times a negative, it just feels like it's negative. It's going to be a positive. So what is -10 times by -7? What's our answer to that one?
Let me see if I could find my. Okay. So. You said -10 times by -7.
That's correct, yes.
Hello, can y'all still hear me?
Yep, we can hear you.
Okay. 70 positive.
Perfect. Nice job.
Yeah.
And the last one, is, oh wait, it's messing up on me again.
Okay.
Okay, unfortunately, well, positive 70 was the correct answer there, and I don't know why it's not popping up for me, but that's okay. How about positive 3 times by positive 4? What's that going to be?
You said positive?
Yes, when I don't have any kind of a sign there, it's just understood that those are positive. So the 3 and the 4 in this problem are both positive numbers. So will our answer be a positive or a negative?
So if they both positive, should it be negative or?
If the signs are the same, so if for both factors, for both of these numbers, if the signs are the same, the answer has
Is
to
it
be
positive?
positive. If the
Oh,
signs are different, the answer has to be negative. So for 3 times by 4, is that going to be a positive or a negative?
so which one is negative, 3 or 4? I'm sorry, I can't hear you because this little girl keep turning up this TV when I tell her to turn it down.
No problem. I completely understand. Both of the 3, can you see my screen? Can you see on the screen that I have 3 times by 4 written? You might not be able to see it.
No, because I'm on my phone and my tablet is charging, so I can't
Gotcha.
see it.
Absolutely. Okay, well then I'll read it out to you. It says positive 3 times by positive 4.
Okay.
So what's the answer to that going to be?
It'll be negative 12.
Because the signs are the same, a positive and a positive, they're the same. So then it's going to be a positive 12.
Positive 12. Oh, so this different than like the negative subtracting and adding when it comes to multiplication.
You are exactly right. And that is why so many people get confused with this. When you're adding and subtracting, it's an entirely different set of rules to solve those problems. And honestly, it is much more difficult to add and subtract positive and negative numbers than multiplying and dividing. So for multiplying and dividing, the rules are very different, but they're very simple. Let me see if I can. So here are the rules for when we multiply.
Okay.
If two signs are the same, it's a positive. If the two signs are different, it's a negative. And that, if you've got your notebook out, it would be a great idea for you to write that down. So when we're solving the problems, you can look at that to help you decide if your answer is going to be a positive or a negative. So
yeah, I'm writing it down right now.
Yeah, write down multiply and then same signs equal positive. And then different signs equals negative.
Different signs equal negative.
Okay. Now we're going to go through some practice problems and you answer as we go. And I'll read them out loud to you because I know you can't see the screen. The first problem is positive 5 times by positive 7. So we have a positive times by a positive. Will our answer be a positive or a negative, Brianna?
It's going to be a positive.
Nice job. And so do you know what 5 times by 7 equals?
35.
You're awesome. That's it. So that one's going to be a positive 35. Now, how about if we had a negative 5 times by a negative 7?
A -5 times by -7.
Yes. So would our
So,
answer then be a positive or a negative?
positive because it's
Nice.
the same.
That's
Okay.
exactly right. They're the same, and that's very confusing for students. But both of those signs are the same. So with multiplication, it means we're going to have a positive answer. So what's our answer for this one?
Difference. So it's going to be 35.
That's it. Excellent. Now, how about the next one is +8 times by +9. Our answer, will that be a positive or a negative answer?
+9. It'll be positive.
Excellent. And do you happen to know what 8 times 9 equals?
72.
You're awesome. The next problem is -8 times by -9. So what's our answer going to be, a positive or a negative for that one?
It's going to be a negative. Wait, if the signs are the same, probably. Yeah, it's going to be a negative because they different.
Well, listen again. I'm going to read it out loud again. It's -8 times by -9.
Oh, they both negative?
Yes.
Oh, it's going to be a positive 72.
That's exactly what it's going to be. Nice job. Okay, I'm going to do one other. Get through our little trick here. One more little practice page, and then we're going to jump ahead.
Okay.
Okay. Okay. The next problem is a +3 times by a -9.
Oh, wow. This is pretty big. And I think
This time we have a positive and a negative. So what will our answer be, a positive or a negative?
Negative 27.
Perfect.
Okay.
And so the next one is -3 times by +9.
Negative 27 still, right?
Perfect. That's exactly right.
Okay.
+7 times by -5.
Negative. -35.
Perfect. And -7 times by +5.
+5. -35.
That's perfect. And Brianna, I think you're just about caught up with us. I had some other practice, but I think you've got it pretty well. So the next thing we're going to talk about, here we go. It's sometimes we're multiplying more than just two numbers. We could multiply several numbers together, and we still have to have a good way of deciding then if our answer is going to be a positive or a negative. And so the algorithm or the rule that I use says you need to count the negative signs. If you have an even number, the answer is positive. If you have an odd number, the answer is negative. So that's going to be another rule you're going to want to write down, Brianna.
Okay, hold on. Okay.
So it's going to say I'd say multiplying more than two numbers.
More than. Okay.
Then you're going to say count the negative signs. And then even equals positive, odd equals negative.
Okay.
Okay, so now we're going to practice some of these. And Tashana, this is just about where Tashana and I were when you joined us. We'll do the first problem because Tashana already did that one. The first problem, you can write it down, is a positive 2 times by a positive 3 times by a positive 4 times by a positive 5. So Brianna, will that answer be a positive or a negative answer, do you think?
A positive.
Absolutely. And then take a minute to figure out what that's going to equal. I was saying before that when you're multiplying numbers, you can multiply them in a different order if it helps you to get the answer. For instance, I know that 2 times by 5 equals 10. So then I could go back and multiply times by 3 and times by 4. Or if you have a system, multiply those out and tell me what you come up with.
120.
You're awesome. That's it. Okay, so now the next one is a positive 2 times by a negative 3 times by a positive 4 times by a positive 5. What's our answer going to be? Is it going to be a positive or a negative?
A negative.
You're awesome because we only had one negative sign. One is an odd number. So what's the answer going to be to this problem?
Negative 120.
You are fantastic. Let's try C. That one says positive 2 times by negative 3 times by positive 4 times by negative 5. Will that one be a positive or a negative answer?
A negative.
Well, how many negative signs did we have in that problem?
1.
Oh, let me read it again. It was a positive 2
Uh-huh.
times a negative 3
Oh,
times by a
negative
positive
3.
4 times by a negative 5.
Oh, okay. So it's even, so it will be positive.
Nice. And what's the answer going to be?
Positive 120.
That's nice. Excellent. Okay, so the next one says negative 2 times by negative 3 times by positive 4 times by negative 5. What's that answer going to
So
be, positive or negative?
was the 2 positive or negative?
The 2 was a negative. So
Okay.
negative 2, negative 3, positive 4, negative 5.
So that is odd. So it'll be a negative 120.
That's exactly right. Perfect. And then the last one of these is negative 2 times by negative 3 times by negative 4 times by negative 5. So will this answer be a positive or a negative?
A positive 120.
That's exactly right. Nice job.
Okay.
Okay, so now we're going to move on to division. And before I teach a concept, I do a quick test just so that I can get an idea of how much you already understand about dividing with positive and negative numbers. So I don't expect you to get these right, but maybe you know them. Maybe you already know the rules. So the first problem is negative 72 divided by positive 8. Do you know what that answer would be? First of all, yeah, negative 72.
Oh, 72.
Negative 72 divided by positive 8.
Well, 72. equals 9.
Hello, Lana.
So-
It looks like you just joined us. We just had another person join us. Okay, so Brianna, have you got it yet? Negative 72 divided by a positive 8.
Is it a positive 9?
It is not a positive 9. It's going to be a negative 9, but that's okay. We haven't learned the rules yet. We'll get to the rules in a minute.
Yeah.
This was just our pretest. So the next question is negative 81 divided by negative 9.
Is that a positive 9?
You're awesome. That's exactly what it is. How about, oh, was that Lana?
Yes.
Hi, how you doing, Lana?
Pretty
Okay,
good.
the next question in the pretest is positive 32 divided by a negative 4. Anyone know what that answer is going to be?
A negative 8.
A negative 8 is correct. Oops. And the last one on the pretest is negative 27 divided by negative 9. What's that going to equal?
You said negative 9?
Yes, negative 27 divided by negative 9.
Positive 3.
Nice.
Hmm.
Now let's talk about the actual rules for dividing now that we've had a little bit of practice. This is the algorithm or the rules that are printed in that pre-algebra packet that comes from the Number Power book. It's a lot of writing. It can be very confusing because there's so much to it. The algorithm that I remember in my head is exactly the same as we did for multiplying. When dividing, same signs equals a positive, different signs equals a negative. That's why I say multiplying and dividing positive and negative numbers so much easier than adding and subtracting them. So when dividing, just like multiplying, if the signs are the same, it equals a positive. If the signs are different, the answer is going to be a negative. So Brianna, I think you were writing down the rules. Go back to where you wrote the rule that said when you're multiplying and add to that or dividing. So your new rule should say when multiplying or dividing, same signs equal positive, different signs equals a negative. You got that?
Uh-huh.
Okay, nice. Okay, so now we're going to do some more division practice. I wanted to expose you to different ways to write division. And so the pretest that we did, I was typing it on a keyboard, so the numbers were side by side. This one actually looks like a fraction. It says positive 28 divided by negative 4. So those signs are different. So our answer or our quotient, is it going to be a positive or a negative?
A positive.
What do you think, Brianna? It's a positive 28 divided by a negative 4.
It's going to be a negative.
It will be a negative because the signs are different. One is a positive and one's a negative. So when the signs are different, it has to be a negative answer. So who knows what positive 28 divided by a negative 4, what's that going to equal?
7.
Perfect.
6.
Negative 7 is the correct answer for that one.
Oh, 7?
Yep, negative 7. Okay, so our next problem is negative 64 divided by negative 8.
Oh, yes.
Okay, so
So
negative 64 divided by negative 8. So is our answer going to be a positive or a negative?
Positive.
Nice. It will be a positive. The two terms both have the same sign. So even though it looks weird, the answer is going to be a positive. So who knows, what is negative 64 divided by negative 8? What's the answer to that?
8.
That's it. And negative 48 divided by negative 6. Is our answer going to be a positive or a negative?
It's positive.
Nice, sure is. So negative 48 divided by negative 6, what does that equal?
8.
It does, positive 8. And so our last practice problem is 49 divided by negative 7. So it's a positive 49 divided by negative 7. So will our answer on that one be a positive or a negative?
A negative.
Negative is correct. So what is positive 49 divided by negative 7?
Negative 7.
That's it. Perfect. Okay. And there, something else I wanted to make sure you were exposed to. Sometimes the numerator or the first number or the top number in a division problem is a smaller number than the bottom number, which is the denominator. And so there's a more easy way to solve these without doing long division. So Brianna can't see my screen, but Lana, you can see the screen, can't you?
Yes.
Okay, so Brianna, I'm going to read out to you the example on the screen. The first problem says negative 6 divided by positive 9. And because our first number, which would be called our numerator, is got a smaller absolute value than our second number, it's going to be easier to rewrite this problem as a fraction. So we can write it in fraction form, which is a negative 6 over a positive 9. So now with our same rules, our same algorithm is going to work. We have a negative divided by a positive. So will our answer be a negative or a positive?
A negative.
Negative, right, because the signs are different. So the answer is going to be a negative. Instead of doing long division, because I've had some students, they take the 6 and they're doing long division to divide 9 into it. And they wind up with a decimal answer, which can be very time consuming, to say the least. You could just simplify that fraction. So the fraction negative 6/9, 3 divides evenly into the top and the bottom. And so the answer becomes negative 2/3. It was just an interesting, helpful shortcut for dividing when we're actually talking about values less than 1 or less than negative 1. So they have a second example, and I'm just going to run through that one quickly if you want to write it down, but you don't have to. The problem is negative 3 divided by negative 6. And then that's rewritten in fraction form, negative 3 over a negative 6. So anytime we have a negative divided by a negative, what's our answer going to be, a positive or a negative?
It's a positive.
Positive.
Nice. And so we could simplify 3/6 to be 1/2. So it's a positive 1/2. Okay, the next two you guys are going to work. And so it's on the screen, Brianna, it's written crossways. So it's the negative 9 and the traditional old division sign, like you might have used in elementary school, 12. So it's negative 9 divided by 12. And so then the first step is to rewrite that problem in fraction form. So when we write it in fraction form, what's that going to be? What fraction is that going to look like?
Negative 6/4. It could be reduced again.
Actually, hold up a second. We would just rewrite the exact problem, negative 9 over a positive 12. So I think, Lana, oh, wait, Lana, hold it up again so I can look at it.
Yeah, that look about right. Hmm.
Let me see. What have you got? -9. We have a little tweak there, Lana. Now I understand what you did. Okay, I saw it. So go ahead and take it down. Before we even start to solve it, we write it with the -9/12. So we write it in fraction form. Now when we're simplifying that fraction, we're going to divide, well, Lana, you know what number divides evenly into both -9 and 12?
3.
3 is correct.
Yep. It's
But
the,
I think you
yeah.
subtracted one time and then you divided the other time. So you have to ask yourself, -9 divided by 3, what's that going to be? And 12 divided by 3.
Okay, kind of pause where you was talking.
Okay,
3/4.
Let's do it
Is it 3/4?
Who said that, Brianna? Brianna,
Yeah.
you're awesome. Yes, that is correct. But let me see. So we have a negative divided by a positive. Will our answer be a negative or a positive answer?
Negative.
Perfect. And Brianna is correct. -3/4. Because -9 divided by 3 is going to be a -3. And 12 divided by 3 is going to be 4. And so that is going to be much simpler than trying to do -9 and using long division to divide 12 into it. Let's try the last one. The last one on the screen, Brianna, says -4 divided by -10. And so because that first term is a smaller absolute value, we know it's going to be helpful to write these in fraction form. And you also know that we've got a negative divided by a negative. Is our final answer going to be a negative or a positive?
A positive.
A positive.
2/5.
Lana showed me her answer, and hers is perfect. So Lana, I want to see if
2/5?
Brianna can get it, but Lana, that you've got it perfect this time. Even the sign, everything.
I got a question.
Okay, hold on. Let Brianna answer it, hers first, and then you can ask your question.
Okay.
I was just saying, is it 2/5?
You're awesome. That's it. Both of you guys got it. Lana, what was your question?
I kind of had a faux pas on the other one because even though, and I guess it's the way I did it, because I guess this is where I get confused at.
Right.
Like, see here where it says 9/12 and came up with 6/4. Then I turned around and came up with 3/2. So I guess I'm not sure when to stop.
You know, you want to know what you did? You had a calculation error. You see when you went from 9/12 to 6/4? You did 12 divided by 3 equals 4, and that was correct. But when you did 9 divided by 3, what's the answer to 9 divided by 3?
3.
3. And you put down that the answer was 6. I think your brain was doing subtraction. You're supposed to be dividing by 3, but your brain accidentally subtracted 3.
Okay.
So no, you were correct though. Had the number been 6/4 and you would keep simplifying, and the correct answer would have been 3/2. You just had a calculation error before you got to that point.
Okay.
Nice job. Okay, so in review, when we're multiplying and dividing positive and negative numbers, if the signs are the same, the answer is going to be positive. If the two signs are different, the answer is going to be a negative. So, and that was all I had for us today. I appreciate y'all coming. It makes